All right, so we are now recording. Let's get started with the class for today. So today we're doing presentations during the second half of today, right? So after the 10-minute break, you guys will do your demos. And then during the first half today, I'll just do a lecture. All right. I do have some reminders. So one of them is we are currently on week 11, right? So that means week 12, we have exam 2. So that's a week. Yeah, a week from today.
What are we?
Yep. It's comprehensive, so it'll include everything, but obviously our LHF will be there, your project, questions about that. Format will be similar, 5 questions, essay type or code or explain. It's a closed notes, but you're allowed your cheat sheet, 8.5 by 11, whatever you want to write on it. Any questions? 2 pages? Why 2 pages?
It's comprehensive. It holds twice as much.
Oh, because you have the old one and yeah, that's fine. You can do, that's a good idea. Yeah. All right, yeah. But it is comprehensive. So I can ask anything from either the beginning of the semester all the way to, so this will obviously also include fast AI, image processing things. Remember, we've covered vision and some concepts such as that. Any questions about the exam? So the exam also will be during the second half of class. Okay. All right. So yeah, so remember we're at week 11 now, right? So we're getting close to the end of the semester. I really want to wrap up this mini project 1 today as much as possible, because I will give you a second mini project, which will be in the image domain, fast AI. And I want it to be just like here you're generating text. I want you to generate images, right? So that you can imagine that's kind of what the whole point will be. You know, you've heard of, just like there's a chat GPT, there's a stable diffusion, right? So stable diffusion generates images. There's GANs, conditional GANs, and fast AI has, you know, art style transfer, something. I haven't decided what the project will be, and I'm open to your suggestions if you want to, everyone wants to do something different, or I'll just assign something more specific, right? So start thinking about that, but let's get the mini project 1 done first, so that we can focus on that for the rest of the semester. So my plan is today I'm going to show object detection, which is YOLO, and it's another type of transfer learning tool. That's very easy nowadays to do. So I'll go over that. And like I said, so we've got object detection, image segmentation, those kinds of things. And then we'll get into ResNets, GANs, CGANs, art style transfer. And that's kind of the semester, basically. I do think I will throw in 1 lecture on something that's really important, which is, you know, you guys have big models, right? And it's taking a lot of memory space. So there's actually a field to deal with that. And there's some topics like the Dilbert, quantization, serialization. So I will cover like 1 lecture on that and give you some suggestions of how you can reduce the size of your models. Keep in mind when you do that, performance might go down a bit. Does that make sense? But that's kind of the semester, basically. All right. Any questions? So you have 1 mini project, maybe 1 homework assignment, we'll see. And then the 2 exams. Well, there will be a final exam during finals week. All right. I'm looking forward to your presentations today. Yeah, and so we'll hold off on till the end of class. And then for what I'm going to do today, if you remember, we're now in the fast AI image processing domain. So I have a new example. So I'm going to do kind of a, let's recap of where we are, right? So we can go to the bright space. Let's go to content. So basically, you know, exam 1, that was all the LLMs. And now we are in the fast AI. So we did fast AI examples to showcase of what you can do. Then we went over foundations, some of the background, right, of images and neural networks. We also, this is what I did last week or 2 weeks ago, right? If you remember, build your own image classifier. Some of you built for fun, right? Your own. Did yours work?
A little bit. It worked when I had like just comparing between two, but once I got up to like 10, it didn't work.
Yeah, not as good. 10, you were predicting 10 artists,
Yeah, 10 like music genres.
music genres, yeah. All right, so this is the last topic that we covered about 2 weeks ago, which was the image classifier, right? So today, we're going to continue, this is transfer learning. So the idea is don't just build a CNN from scratch to classify cat versus dog, right? That's more of another course. This is transfer learning. So what else can you do with these tools? And so today we're going to look at another use case that's very popular, which is object detection. All right. And so I'll talk a little bit about, what's going on there, but it's images basically. And you can do a lot with fast AI, right? Leverage, or sorry, we're not using fast AI in this one. Instead, I'm going to show you YOLO, which is, it's like another framework, if you will. Okay. Any questions? All right. So I provided the Jupyter already. It's this one. I'm just going to follow it. There's some data, so I'll talk about that. I'm going to motivate like a use case of, somebody might ask you to do this. So it's watermelons here. So I'm gonna need to run this on the GPU hub or the GPU cloud. So let me go there. And then we'll just run through the problem. Let me get a GPU. Okay, here we go. All right, so I'm going to request a GPU. Okay, so let's start here. I'm going to create a new Jupyter for this. I'm just going to call it in class. Okay. Okay, so we're processing images, doing different things with images. Last week we did, or 2 weeks ago, we did classification of CIFAR 10. So that was the data set that we used, CIFAR 10. And that's, the basic thing. You saw that with that approach, you can build, an image classifier really quickly, and it uses transfer learning. What does that mean? It's using an underlying thing called a ResNet. So a ResNet in the image world is equivalent to a GPT in the LLM world. So I will do a lecture where I'll go in a little bit deeper about these ResNets and BGGs, but at the end of the day, they're just very deep CNNs. Now they are pre-trained, so that means you are downloading the architecture and the weights for the ResNet. Does that make sense? So we've seen some examples of using that. YOLO and all these tools, I'm pretty sure the underlying framework is also some type of a ResNet, etc. But these are wrapped, just like Transformers wraps, a lot of code around the very basic things. Here we're going to wrap a lot of code around these ResNets to do object detection. Okay, so now the use case is going to be, a little bit different. Okay, so to motivate this problem, let's imagine that I'm going to give you a problem, right? Let's say that you're hired by an agriculture company, maybe a smallish or medium-sized agriculture company, and they in Georgia or something, and they produce watermelons. Watermelon is, a thing they sell, right? So it's important for them to know what's a good watermelon, what's a bad watermelon, and how do they do that? They measure some dimensions, right? In fact, they have like 16 or 20 different things that they look at to quantify if it's a good watermelon or the species of watermelon, all that stuff. And maybe they use that information to predict, forecast, or sales, revenue, all that, right? Anyway, that's what they need to do. The first thing you need before you can do all of that is find the watermelon in the picture. And we're making the assumption that, you know, there's some camera or something and it's taking pictures, right? And of watermelon. But still, you know, there's going to be some difficulty there and challenges, okay? So how do we do object detection? Well, you can do it from scratch, of course. That's, you know, entirely up to you. Or you can use a framework that exists today. So for object detection, there is a framework that exists today called YOLO, Y-O-L-O. And I think it's up to version 8 or maybe 9. Okay, version 9. I'm using version 5. That's my example. You feel free to bump it up to whatever version you can, okay? And so I'll demo how it works, but that's the use case. I have pictures of watermelon, and I like these pictures because they're challenging. So I want to, it's not perfect, but so, you know, the problem that I gave you is not solved just by my script, right? But you need this script to keep going. Does that make sense, guys? All right, so let's go ahead and take a look at the Brightspace environment. So I'm going to go to table of contents. And I added this new, well, I moved this module to here. Again, for those of you that came in a little late, exam 2 next week, please do not miss the exam. Okay. Object detection, right? So this is what we're doing. So I have another, this is just another example of detecting airplanes, and I'll kind of talk a little bit about it. It's just 2 examples. I won't demo this one, but I will demo the watermelon one. For this, you will need data. Okay, so I loaded a zip file here, which says pictures for machine learning. So if you want to replicate this on the GPU Scholar later on, you'll need to download this and upload it to Scholar, okay? Right. And this is the Jupyter that I'm going to follow. So here's some information if you guys want to read about it. But the script that I'm using is this one. All right. So we're gonna do this. Right, you can read, you know, YOLO. All right, so this is the environment. This is the code. So the first thing we are gonna look at is the data. All right, so I'm going to rename this in class object detection. Okay. All right, so let's go to here. You can see I already did all of this. I basically I downloaded that zip file, right, to my downloads. Then I clicked on upload here for this is the GPU Scholar, right? Then I look for that zip file, right, in my local computer, and I hit upload. It takes a little bit. It's a big file. It's like 1 gig. It's 1 gig. And then it's this one, pictures for machine learning.zip. Okay. So then what you need to do is you go to cluster, open Scholar shell. Okay. Remember your my quota. So I'm almost full here because that was a big file. Then you navigate to your desktop. And so it would be this one, pictures from machine learning.zip. Then you type unzip pictures. And you can't see it, but it's there. So you can see that there. I'm not going to hit enter because I already unzipped it, but you hit enter, it's going to unzip it. Okay. And then you will get this folder, pictures for machine learning. That's the actual data. Okay, so let me do clear here. Oh, sorry. Clear. So now CD into pictures of machine learning. That's -L, and that's all the images basically that we're going to look at. Okay, so these are watermelon images. Okay, any questions? Okay, so we are going to now start the process. Okay, so the idea here is we want to read in that data, and we're not going to do any fine tuning or any pre-training. This is just inference. Okay. But obviously, I'm going to discuss a few things about this. All right, so any questions before I begin? All right, so let's go ahead and get started. So I'm going to copy the libraries basically for object detection and then describe them a little bit. But they're all pretty familiar. Okay, so Torch, I'm going to run this section. Torch, NumPy, Pandas, Matplotlib, Torch Vision, sklearn basically. So pretty standard libraries. Okay, you can see I didn't get an error. You will need to install something because we're going to use a lot that library YOLO, and YOLO uses something called OpenCV. OpenCV is like a library for image processing. So it's based on that. Okay, so if you don't install it, it might give you an error. So I'm going to go ahead and just show you, where is it? Here. Seaborn you probably don't need, but you would need to run this one. Okay, so hit, that, run that cell and install OpenCV. Once that's installed, that's basically then YOLO should run, at least my version. I'm using version 5, right? So I don't know, other versions might be a little bit different. Okay, so once that's defined, let's go ahead and now I'm going to grab the data, right? So the images basically. So full path, I need to specify what my path is here on the desktop. PWD. Okay. I'm going to replace this here. All right, so we're going to read in the images from that into full path. So that's just adding the string. Then we are going to load the images. Okay, so images full path. Basically, we're creating a list. Okay, we're going to iterate and grab all the JPG files in here, and you can print them. You can see you have them available there. Okay, we might want to look at one image. So you guys know how to do this, right? How do we do this? I have some code. Okay. So I'm going to use pill image to look at an original image. Here we go. Right? So I have the full path here, right? And I'm going to need to add probably this one. And then I just need one of these files. So directors list some image, correct? So I'll just grab randomly 17, right? And then I'm going to use T, which should be this one, Torch Vision transforms as T, okay? And then I'm just going to do pill image to pill image, read image, and all of it. And then run that one. So it's, oh, yeah, it should be detected full path. What is it? Full path, right? Or images path. Sorry. Images path. Actually, I'm going to print this. Just to make sure I have this correct. All right, so yeah, that should be correct, right? So those are my images, and now I'm going to read in one. Okay, I read it. And then I'm just going to print it out or show it. There it is. So this is the problem as I was describing it. So imagine you were hired as a consultant for an agriculture company, right? And they want you, they don't just want you to find the watermelons. That's the easy part, right? So that's easy. They want you to measure these watermelons. You see what I'm saying? Like measure like the distance and that and that. I'm not asking you to do this unless you want to do this as a term project at the end of the semester. But but it's basically just I'm just kind of like motivating why you would use this. Okay. So to do that, the first thing we need to do is find the watermelon. If you want the distance, the sizes, do you need part of the floor included in that image? No, right? So then maybe you want to crop it also. So you want to like crop out the thing that you detected and just use that. But they provide this board and this thing here. And these things are actually useful because this is color contrast. So if maybe they want to look at how red the watermelon is or how pink it is or something like that, right? And so I don't know if you guys know this, but like when they went to the moon, for instance, right, and they took pictures of the moon, they also had a little color grid so that they know what that color grid looks like on Earth. And so they could like, whatever the colors are in the picture, they could match them to the color grid and adjust it accordingly. Does that make sense? Yeah, so this is the same idea, right? So that's included. So that's for coloring. So then you probably need to get that information out. And then this one might be, oh, there's a ruler in there. I think the ruler is for the actual, like having some reference. So you maybe want to crop that out. Anyway, there's a whole bunch of things you want to detect, a whole bunch of things you want to crop out, right? So how do we even begin to tackle such a problem? So transfer learning can help us out because here transfer learning is being used in a package called YOLO to help us to get started with solving those problems. Okay, it won't solve all of those, but at least it can get you the detection and the cropping going, and then you figure out the rest. Got it? All right, so this is the image. So we've got one, and there's several images. So I could grab another one. They all kind of have the same format. So I can try image, let's say 50. And you can see this one, there's feet in there. So there's like a person in there. You probably don't need that information. Notice that the board has been moved a little. The watermelons, you know, may be different. This is different, I think. This one has seeds, right? The previous one didn't have seeds. Do you see all that? So there's going to be some complexity there. However, surprisingly, YOLO works really well for finding things such as this. So that's the beauty of it. All right, so now we have this idea, right? This intuition. So now let's just get started and try to perform the object detection. Let's get it here. All right, so I have 295. Did I print these already? Okay, but I haven't printed the quantity, so let's start. All right, so I printed the number of images, then I'm going to print the length of the list. Okay. 295, right? So we have 295 images in there. So now we want to perform some kind of inference. So what do we do? What do we use? So far in this course, you have learned, if you want to do LLMs, you go to Transformers and the Transformers Hub. If you want to do images and maybe a few other things, you go to Fast AI FastAI will provide you the resources. Though, but there are several other things that you can use for transfer learning. In fact, Torch and TensorFlow have their own hubs. You know what I mean? So like they have their own PyTorch hub. And you can reach that, you can see here by just invoking torch.hub.load. So if you're curious, you can go look for that, the hub for PyTorch, and see what models are available. So in my example here, I'm downloading from that. Where they get it from, I don't know exactly, but at least they're managing. Make sense? And this, when I'll do probably another example, at least of these, where we get from the hub a ResNet as well, right? So, but this is a third in this course now. You have transformers, FastAI, and you have one directly getting pre-trained models from the PyTorch. Okay. So let's go ahead and do that. I'm going to copy this code here. All right, so I'm going to go over here. Now notice I'm using YOLO 5. So YOLO 5N basically. Monica, you said you know that there's a YOLO 9 at this point. So these are constantly evolving. It probably has some nicer features, etc. But this one still works for me, so I'm just using this example. All right, so basically it's the same idea as before. You want to create a variable called model. That's going to be your model. It's going to get an input, predict an output. Pretty similar. But because it's object detection, there's some difference there, right? You know, we got to think about what are the things that we want. Could you fine tune this? Yes, right? You could fine tune. So YOLO comes with like a pre-built set of like, I don't know, 100 maybe things that it, not only is it really good at detecting an object, but it also tries to label it. Okay, and that's limited. Obviously, how many items are there in the universe? Many, right? And so it can't have all the classes, but it has things like person, vehicle, you know, things like that. All right, so we're going to see if it works. So a person, when we think of a person, what does a person, you know, you think arms, a head, right? That's what a person should be. But we saw in the pictures that we had shoes. That's a person. We know that's a person, right? If you see some shoes, you get concerned, right? But so could YOLO detect it's a person? Let's analyze that. All right, so the first thing I'm going to do is load the model. So my model already, if you haven't installed OpenCV here, it'll probably error out. That's where the error comes in. I've already ran this, so I already have all these. It might also take you a while because you are at this point downloading a pre-trained model. Okay, so this is going to be big. Okay, so mine runs quickly. It's probably running, loading it from cache, but you guys might. Yeah, so here, I don't think it says the size, but you know, all right. Okay, any questions so far? All right, great. So I have now my YOLO model, and remember, currently in this example, all I'm doing is inference. I'm not going to fine tune or anything like that. So now what I want to do is I'm going to want to predict. Before that, there's some parameters that you can change. So I'm not going to change any parameters, but I'm going to show you at least how you could do that if you decided to do that. Okay. So there's, you'd reference the model itself, and then it's got parameters like confident thresholds, basically, you know, multiple labels per box, you know, and things like that. One important thing to note is that these object detection models were trained on something called the COCO data set. It's like a very large data set. So if you've heard of ImageNet, and there is a specific one, it was probably a competition, honestly, of object detection when they were still working on that. But this is the classic. Okay, so TensorFlow and PyTorch have their own versions initially, and now YOLO has dominated, basically. I think it's probably a company, I would say, Ultralytics, I assume. Okay, everyone with me? Everyone with me? All right, great. So anyway, I'm not changing anything, but this is how you would go about changing some parameters. All right, so I hit run on that one. Now I'm going to go ahead and we're going to try to do some inference here. Copy this. Run. All right. All right, so let's go ahead now and perform inference. That's pretty much, so that's where we do this. So I'm going to pick an image, a file name. So from the directories list, I'm just picking image 34. Okay. Specify the full path. And then here we invoke the model. We give it the image and it should give us some results. Got it? Yeah. All right. So a couple of things that you can see, YOLO from like by design can also crop things. So like the things that it finds. So basically when you talk about object detection, there's this big idea of bounding boxes. Okay, so there's going to be these bounding boxes. And so these bounding boxes are basically points on the image, like the minimum and the maximum point. So it's going to be like min XY, max XY. And from that, you can do the math to find the box around your object. Does that make sense? Okay. So that's basically what it will predict. It will also create the crops. And if I say, so notice the model returns results, and then you can say results.crop. So this is basically crop detections dictionary. So it's going to actually take the crops and put them in a folder in your file system. So I'll show you where that is because it's going to do it on the Scholar here in that environment, but it will crop the images, whatever it found. So let's say it took a picture of you guys, right? And it cropped like Joey, right? So then Joey's just goes into a folder labeled also by, person. But it also found a bird flying, so it cropped the bird and maybe it said it's a bird. Okay, so it's not always super great, but at least that works a little bit. And then, as I said, you can fine tune this if you would want to. All right, so so basically that, and then save the results. So I'm going to go ahead and hit run, and it didn't work. Okay, I'm missing a / here. Okay, so just to separate the file from the directory. So let's run this again. Okay, so you can see there, it created in runs, by default, it creates this folder called runs, detect, so the things that it detected. And then in there, now we've got exp3 and exp4. So we can take a look at that as the cropped items. Okay, so we'll go into the file system to find these. This is better actually because you may want, and I'll show you an example of how this could be used. Okay, so now that I've performed the inference and I have my object detection, I want to process the inference and just look at what information is available. So I'm going to go ahead. Yep, here. So V, cell type, markdown, run. All right, so I'm going to print some information here. Okay. All right, so it says image, gives you the dimensions. Notice that it doesn't care about dimensions, right? So that's one of the things with this. It'll work with your images. But probably inside the ResNet is resizing, right? So it probably resize, I don't know, to 256 by 256 or maybe 1000 by 1000. It depends. These may be smart enough at this point that it detects what GPU you have, and based on that, it selects. All right, it detected one person, one Frisbee, one sports ball, one apple, one orange, one oven, one book, one teddy bear. That's what it found. It may not even have class watermelon in its, because it only has, let's say, about 100 labels but it found maybe Frisbee is the watermelon, right? So we'll see, right? So, but the point is you could then, you know, I have found in my experience that the object detection is really good. Like the bounding box is good. And so then you can use that and just fine tune it to whatever your classes are and find watermelon or something, okay? So it gives you other things like speed, inference, and, you know, all that stuff. All right, so now we have data in results, right? So we can further look at things. So now I'm going to show you how we can access some of these results. Okay, so from results, XY, what does that imply? The bounding box, right? It's XY. So remember, all you need is min, max, and from there you can just use like geometry and things like that. You can work out the equations to do it yourselves. All right, so you can go over here. There's the data, okay? But we want to look at it in a little bit more presentable fashion. So it's got a feature for that actually, which is built in. That's the beauty of using YOLO. You don't have to like process that to make it more presentable. It's just built in. So then you hit pandas, obviously that's what they're using. So results, pandas, and then the same data. So you can go ahead and look at it. And now we have the information, right? So these are the things that it found. So notice the classes go class 47, class 73. If I remember correctly, the COCO data set had about 100 labels. So that's probably where that's at. These are the things that detected: Frisbee, Apple, book. It provides the confidence, which is really useful. So why is this useful? Because you can say only show things with a confidence higher than 10%. Do you guys see that? Probably you shouldn't expect these confidences to be 100, right? But use it for a ranking. So then, you know, you could do that. If we go back to these over here, I wonder if those can be, so model confidence threshold is 0.05. Do you guys see that? So these are probably all above 0.05. So I can, in fact, make it 0.01. I'll get more labels. I make it 0.10. I'll get 4. If I make it 0.20, I will only find one item. But this is useful because by default, it doesn't just find one object, it's a multi-object detection, and it puts the bounding boxes in the image. Is that clear for everyone? Okay. And you can tell it to crop automatically so that you can literally do image extraction. You can extract things from your image and use them further, okay? So here, this X min, Y min, and X max, Y max are exactly what is implied there. You only need 2 dots to determine the bounding box. So don't even worry, you know, because you can just make a rectangle, right, based on these coordinates, and boom, find the objects that you're looking for. All right, so we've got that data now. So we can continue here. Okay, so you can do it. This is just to show you. This is like operating in pandas. You can sort things by a specific value. So this is being sorted by X min. So you can run that. Let's save. All right, now we want to view the image. This is the actual image with all the objects that it detected. We're going to do that to view sample predicted image. Cell type markdown. All right. So now I need to figure out this path, right, of where the predicted images are. So it'll create this runs detect. And I think I saw here it told me where it put things. Yeah, XP3 and XP4. So save results to XP3. saved one image to XP3, saved one image to runs detect EXP4, okay? So let's grab data from there, right? So EXP3 and EXP4. So let's go. So I'm just going to do EXP4. Okay, so that's the path. And then we can navigate to that path just so I can show you what's there. But this allows you to retrieve the images and view them in a nice way. So we can make sure there's a file there. Okay, okay, there's one image there. If I do 3, was it 3 and 4, right? 3 and 4. Yeah. This is 7424. Crops. So in here, we have one image and also we have the crops. So we want to probably access these files also. So we'll do that in a minute. But this is like out of the original image, it extracted new images of the objects. So we'll explore that. All right, so let's keep going. So now I'm going to go ahead and just use pill to view the image, but it's going to overlay everything, all the information. So we read it because, so how does it work, right? So the way that it works is there's the original image, right? And then what does it do? It applies the object detection, and now it's got this pandas frame of the X-mins, X-Ys, and the class, right? And that's a separate piece of data. And then it takes the original image, uses the results of this to overlay the bounding boxes, the label, and the confidence, and creates a new image, and it saves that image so that you have everything in a nice way, but also you have a pandas data frame that you can use for further processing. Does that make sense, guys? Yeah. Okay. So any questions so far? Nope. All right, so let's go ahead and hit run. Okay. What is this? Oh, yeah. So EXP4, sorry. I played with them. It tried to visualize crops. And then I'm going to work. Yeah, there we go. Okay, so now comes the analysis. So you may have expected this to be really good, or maybe you're not impressed or impressed. It's up to you. But here is how it works. So it generated, the original image, the pandas data frame with all that information, X-min, XY, confidence, and the class, took all that and generated a new image, which is the result. So it thinks this shoe is a teddy bear, but there's a red over there. That might be a person. So it actually, we'll pick another image, probably. It thinks this is a book. You see that? It found the table probably, and it thinks it's an oven. It found this and it thinks it's an apple. And it found this one and it thinks is a sports book. Yes. So what do you think? What's your conclusion here? Remember, it doesn't have the class watermelon, first of all. So it's saying it's a fruit or a ball, which is reasonable, right? But you could always fine tune this for your problem to, be more precise. It's never going to be perfect. And you have the bounding box there and the confidence interval. Do you see that, guys? Make sense? So from here, you have to do, this is what YOLO gives you out of the box. So obviously now you'd have to go in and take it further, right? So I would probably want to become really good at predicting here some kind of fruit or something in the fine-tuning stage. And then I would want to crop this and that. And remember, our question was, how do we measure the sizes of the extracted fruit? Now, if you notice, one thing that it does really nicely is that the bounding box is just around the edges of the the thing that it detected. So for instance, if you notice this whiteboard is kind of slanted, unfortunately. So it can't do that, at least not YOLO 5, right? Maybe in the future they'll work on that one. So it can't do that, but it's pretty good. It takes like the points and it draws the bounding box around it, right? So anyway, that's kind of the idea. Does this make sense? And that's what object detection is. That's what you can use it for. So now it also took the crops, right? So it cropped the data. So you want to maybe take a look at that. But it generated these crops and put them in another folder. And so now you would want to use it. So Sports Bowl or Apple is going to have watermelons, right? So when you're writing some code, if you run this for all the images, you can then start searching for all the cropped sports balls or apples. And now you're going to end up with just images of the watermelon. Okay. Any questions? All right. So let's go back to the code here. So we ran this. This is another example, actually, that I have on the GitHub. And you can see now it's said it's a person with a 20% confidence. I noticed that this is red here. So this is probably also saying it's a person, although it's kind of overlapping. Okay. So in this one, it thinks that the whole box here is a traffic light, which actually makes sense, right? Because there's a red, a green, and black background. So that's a traffic light. Do you guys see that? So, I mean, it's technically correct. It thinks this is a Frisbee and this is a Frisbee as well. Okay. And the confidence is actually 23, 28. So that's good. This is, it thinks that's a refrigerator. All right. Any questions on that? Okay, so the next thing we want to look at is the cropped versions of this. So we will need to look at the folder for this so I can kind of figure out, because I don't know the names. So let's go back to the shell right here. I'm going to hit clear. All right. Oh, yeah. So I need to get out of here. All right. So if you notice, it created this folder called runs, because this is where the Jupyter is running. Notice there's YOLO5n.pytorch. So that's the model. This, of course, is the images. And my Jupyter is probably in here. It's called in class. This one, object detection. Okay. All right. So now we're going to go ahead and go into runs. So I'm going to do cd runs. L. You can see it's got detect. So you can go into detect. All right, so we have exp2. Every time you run it, basically, it's going to generate a new one, okay? I had run this earlier, so that's why there's a 2-1 in there. So let's look into these. So exp4. Okay. Huh. Okay, slowing down. All right, so I've got an image in there. Okay, so these are not the crops, apparently. Yep. Okay, so then the crop, so every time I'm noticing every time that I run FastAI, it just generates 2 folders, right? So if I run it with another image, it'll probably create exp5 and 6. 6 will have that image and 5 will have the crops, basically. All right, so let's go into exp3. Okay. CD. Oh, I'm still in. Yeah, so CD exp3 clear. All right, there's the crops. So now we can go into that folder, CD crops, ls-l, and basically it creates folders for the classes that it detected in case it found multiple. What if your task is, well, actually multiple watermelons, right? So you would want maybe them to be in there. All right, so we have Frisbee was one of them, right? So CD Frisbee ls-l, and that's the image. Do you guys see that? So I need to get this path, PWD, and the name of the file is this one, IMG 7424. All right, so let's actually. Okay, so this I need to look at that image, see what it is. So look at the cropped images. Okay, there we go. So I'm just going to copy the same code I used before up here. This one, right? Sample image. And I just need the path here. I'm going to say, all right, so I need this sample image path, which is just going to be what? It's going to be this detected one, right? Detected one. And that image 70, actually, I can just use this name. This will work. But I need to modify it a little bit. So I'm just going to hard code it. It's probably easier. Okay, so what would it be? I need to go here, copy this frisbee, Control copy, Control V, there we go. So add a, like that, correct? Yeah. And then we add this path here, plus IMG underscore, was it 7424? And I think uppercase JPG. Right? So hopefully that'll work. So let's run it. Okay, maybe not. Oh. What is it? Oh, maybe lowercase JPG. Okay, so lowercase JPG. Let's try it one more time. Okay, great. So now let's try to visualize this image. Like magic, right? You're not impressed by this? I would be very impressed by this. All right, so anyway, so it does a lot. And this, the point is, transfer learning does this out of the box. We've done no fine tuning, no nothing. We're just doing inference, and we can find the objects. We can crop them out. And then the only thing is, if you wanted the correct classes in here, then you'd have to do fine tuning, basically. Any questions? All right. But actually, sometimes you can, if you don't want to do that amount of work, my experience, as I said, is that it's actually very good at just putting the bounding boxes. So you can look at it as two tasks, and it provides bounding boxes with labels. If bounding boxes is really all that you need, go with that. Crop it out and then do further processing. Any questions? Nope. Pretty easy, right? So yeah, so we extracted this. Let's just do one more image here. So I'm gonna pick another image. So I think I used image 50. So let's use image 15. Let's start at the beginning. Okay. So this image, Okay, so oh, this is like an interesting one, right? So this is another image. There's a person there, some dirt now. The ruler looks a lot better. Let's see if it picks up the ruler. The watermelon looks interesting. Okay, let's see what it does with the cropping, right? So maybe it'll, okay. So let's, okay, so it's 295. Download YOLO again. Some parameters. We can go back to the threshold or confidence if we need to. Inference objects. So now we want to infer on 15, right? So 15 is that image. I'm gonna go. Yeah, I want this image, so 15. So let's take a look at it. We're gonna basically predict, do the cropping, etc. Okay, notice it created 5 and 6. As I said, the folders 5 and 6. We can print the results in a very text readable version. It found a bird, 2 apples, a book, and a teddy bear. Okay. All right, so now let's run through this one. That's the data. We can look at it as a pandas frame, data frame. So there it is. Notice the confidence intervals are low always, right? So they're not, don't expect them, as I said, to be very high. We might actually, you know what I'm going to do? I'm going to lower that, or yeah, lower that threshold because it's at 0.07. So I guess there was nothing at 0.05. But let's just lower it, get it very low. So if I do 0.1, it'll probably give me a ton of, actually, let's try that. All right, so let's do that. Okay, 7 and 8, so another set of experiments. See, it now detected more classes. So I've got one person was found, car, bench, bird, bowl, 2 apples, right? So multi-detection, which is really nice. 1 dining table, 1 laptop, 1 oven, 1 book, some scissors, and 1 teddy bear. Let's see. Okay, there's your data. You can see some of these have a very low confidence. So bench has the lowest confidence, it seems. Okay. Apple, hopefully that's the watermelon. So let's take a look. Now it should be what? 6, right? 6. So let's remember this number, image 7369. Okay, so now we are going to display it. There it is. What do you guys think? How would you rate? Would you use this tool? Teddy bear, it thinks that's a teddy bear. Okay. Two apples, see that it marked this as an apple and that as an apple, so it can do the multi-object. Any questions? Oh, yeah, that's what it is. I was thinking, why are we missing some bounding boxes? But it's because I ran the experiment twice. So if I want to see more bounding boxes, what do I have to do? I have to change this to 8. Right? And then hopefully I'll see the more bounding boxes. Same thing. There they are. At some point, this might be too much, right? And so not helpful. But there you go. So I was curious to know what the scissors were, but I don't see them. Oh, this might be, it thinks maybe this thing is the scissors. Yeah, right? It seems like it says scissors. Yeah, there you go. Kind of makes sense, actually. So yeah, so that's object detection. Any questions? Pretty straightforward. Okay. And then as far as grabbing one, let's just grab apple. There might be 2 apples in there. Teddy bear. Let's do teddy bear. So teddy bear. Okay. Let's run this. The number would be 7369. And then this would be experiment 8, no, 7. Crops, and then this would be teddy bear. I guess like that. Right? Okay, so let's try it out. There we go. You can crop out that part of the human and works perfectly. All right, so that kind of concludes the example for today of object detection. So let's go back to I don't think I missed any code. I've shown you how everything is stored. We can go back to the Jupyter. I do have another example, but I didn't provide the data because I can't share that data, but I do have the Jupyter, another one here. So you can click on code. And I think, yeah, so I'll discuss this. Yeah, so this is just another example, very similar idea, but with Ultralytics here. It's kind of a similar code. This one is just detecting airplanes, right? So maybe you want to build a classifier of airplanes flying in the air, right? So if you want to do that, you don't want to have all that blue background, right? So you just want to find the planes in flight, crop them out, and then somehow, assign the class. So that's an example of the image. And then here you can see, look at how far up in the air it is, and it works. And it tells you it's an airplane with 0.79% confidence, right? What are these called? Contrails or something? These are not even showing. So just the airplane there. And then it's, you got the bounding box. So it can get up to high confidence, as you can see. Oh, yeah, let's do that. So this is another example of an airplane in flight. And you can see that's a confidence of 0.94, and it's cropping it or providing the bounding box, basically. I also tried this, which is like hand-drawn or cartoon, maybe. And basically it thought this was a boat, but it did find the profile of an airplane with 0.36 confidence. Another airplane, 0.94. Yet another airplane in another angle, 0.94. And it's got an obstacle. So this one has an obstacle, and notice that no issues. It's got letters and everything. And then you do the cropping, and that's it basically. All right, that concludes YOLO. I'm not really going to go any deeper than this. Okay, just kind of showcasing some of the things that you could do with transfer learning. Probably next time around we'll take a look at something else next week. Are there any questions on this? Okay, great. So this is just, as I said, another example of using transfer learning. We used it from not Fast AI, remember, or Transformers, but this time around we use the GitHub, or sorry, the PyTorch hub to load the models. Okay, and I'm not going to provide an example of how to fine tune it or anything like that. So we're going to move on to another topic. All right, so that concludes the lecture for today on this. And then as we discussed during the second half of today, we're going to do the presentations. Okay, so this is I'm going to stop this one.